Right, this is the second proof on that worksheet that we had. This is proving that sine A minus cos B is equal to sine B minus cos A, and then got something similar on the other side, only the signs are changed. Well, there's a lot of ways to start with this. A lot of people try to cross multiply and then prove that. In the traditional proof we cannot do that. We're just going to start with one side and go towards the other side. So if we start off with the left hand side, which is sine A minus cos B all over sine B minus cos A. Now the trick for this is, on the bottom line, that is what I'm going for. I'm going for that as my denominator. So therefore I'm going to force that to be my denominator by multiplying both the top and the bottom by cos B plus sine A over cos B plus sine A. Now I'm going to leave this part here. I'm going to leave that because that's what I want as a denominator. So I realize that obviously something on the top line, once I expand it all out, is going to factorize. So then this part here will then cancel. Right, so if I actually expand that out, that's actually going to give me a sine squared A minus a cos squared B all over. Now I left this bit over the other side here. I left cos B plus sine A, because I know that's what I want as my denominator. And on this side here I've got sine B minus cos A. So what I'm going to look for is something on the top line's got to factorize with something on the bottom line. At the moment the signs, this one's an A and that's a B, and this one's a B and that one's an A. They're round the wrong way. So the simplest way to do that is to use the fact that I know that, for example, cos squared A is, if I do cos squared A 1 minus cos squared A is sine squared A. And I know that 1 minus sine squared B is cos squared B. If I use those two facts there, then I'm going to get on the top line 1 minus cos squared A minus bracket 1 minus sine squared B. And this is still all over what we had on the bottom before, which is just sine B minus cos A over cos B plus sine A. Almost there. 1 with a minus 1 cancels each other out. Negative with a negative makes a positive. So I'm going to be left with a sine squared B, and then I've got a minus cos squared A, and all of this is still all over sine B minus cos A, and this is still cos B plus sine A. Right, this bit up the top is just like a quadratic. That's just a difference of two squares. That can just go into sine B minus cos A into sine B plus cos A. So the top line factorizes into a sine B minus cos A and a sine B plus cos A. This is still all over sine B minus cos A, and we've got a cos B plus sine A. Now we've got that cancels with the one on the bottom, and we are left with the right hand side, Q, E, D. Right, let's go back up a little bit. When we're actually doing this, the very first thing we did, we started with the left hand side, and then what we did is we knew that this is what we wanted as a denominator, so we just multiplied by it. and then we left it by itself on the bottom line here, and then we knew that the top line had to in some way factorize out so that that there would cancel. The next step that we then did, this is the only identity that we actually used, which was over here, the cos squared plus sine squared equals 1 identity. We knew that we had a problem with the fact that we had an A on the top and a B on the bottom. So we had to get this all in terms of a B, and that one there, the coses, all had to get all in terms of A's, and the sines all had to get in terms of B's. So we just used that standard identity. That sine squared A is 1 minus cos squared A. Now we've got the fact that cos A's were the cos A's, and sine B's are with the sine B's, so they can start cancelling out. Then we got up to here, we've got a perfect squares, difference of two squares, which we know is just the first one minus, the second one plus. Then it cancelled and it all fell out. So really only took a couple of lines. 1, 2, 3, 4, 5 lines before it came out. The thing that you have to be very careful of when you're over here, there are lots of different equations and identities and things that you could start using, and you go down the wrong track very simply. Always keep your eyes on what you are going for and then try to force your proof into that way. Okay, thank you very much.